The output design template command will cover all of those design exercises which can't be completed with one of the other predefined wizard-based design options that are covered in the other tutorials. Let me just give you a bit of context here, and I'm going to show you what we're starting with. So we're starting with an excavation design, and we've got the original ground level survey. What I'm going to create here using a template is an earthworks mound or bund, which will start at the edge of the excavation. It will go up 5 meters and across 10 meters, so that's a 1 in 2 slope. There will then be a 2.5 meter flat top, and then it will intersect the ground model at 1 in 2 and then create a point where it intersects. If in the unlikely event that the ground model rises steeply and my bund ends up in cut by the time it's completed the flat 2.5 meter wide top, then there will be a cut command inside the template in order to cater for that situation. We select Output, Design Digitize, Template, and because this bund, this earthworks mound, is going to come back into the current survey, then we don't need to create a load file name for it. We select the template description file we wish to use, and when you install the LSS program you will have also installed test data. That will either reside in the surveys folder or surveys test data folder, and the subfolder called TDF, which stands for template description file. There are a number of example template description files in this folder, all of which are referenced in the LSS help documentation, and they all have a name which gives you some indication of their contents. The one we're going to look at is the bund template description file. We can select Edit and view that file, which is a simple text file. Any line which begins with comment and a comma is ignored by the template command. It's just there for notes. What then follows are a series of commands, which again are all documented in help. But the first one we've got is lateral. Now lateral is different from a fix command in that you only define a horizontal offset and not a vertical offset. And what this will rely upon is going out from the edge of this excavation into a blank area, but getting the level from the ground model. So it goes out 2 meters, gets the level from the ground model, and then places a feature code BB. It then creates a fixed slope which goes out a further 10 meters and up 5 meters and a top of bank. That's the top of the bank itself. Then fixed 2.50 is a 2.5 meter wide flat top, and again top of bank feature code. And then if in a fill situation, i.e. above the ground model, then intersect at a 1 in 2 slope and then put a feature BB at the base. If however it's in cut, then intersect back up to the ground model and this time put a feature TB in there. So that's how this works. Let's go ahead now and apply this template. So we begin the design from the levels of the other survey. Bear in mind that we're going to do a lateral offset of 2 meters, and we need to be able to find a level out here which we don't have in this quarry design. So we get the level from the ground survey, we design up and back into the same survey. It confirms the lateral offset value that we have inside the template description file. We'll design to the left with a maximum point interval along the line of 5 meters, and we're going to design a closed loop. I'm going to choose the option in mode string of observations, whole string, and I'm going to go clockwise. You will then see that it has created a 2 meter offset, 10 meter wide, 5 meter high bench, 2.5 meter wide top, and then a intersect slope back down to the original ground survey. Save and load. And now when we do the section through the model, we will see that the slope design comes out, 2 meter offset, slope up, flat top, and then intersect slope back down again to intersect the ground on both sides.